Hello and welcome back to Mr. Lamb's Science Corner. Today we're going to do not quite a demo and certainly not a lab or a math, but we're going to talk about a Swiss psychiatrist named Jean Piaget, and that's probably a bad pronunciation, but it's as good as I get, who back in the 20s and 30s came up with a theory of I guess I might call it intellectual development. And what he found is that children undergo 4 stages of development to get to the epitome of where everyone is, which is, of course, that of being a teacher. And I'm not going to get into a whole lot of detail about this. This is not going to be a must-do lecture about that, but I want to show you something that he came up with that is kind of a demo and I find interesting. So certainly Google for Piaget. You're going to find at least Wikipedia article. I looked at it briefly, and if I didn't know a lot about Piaget already, I would certainly say I'm looking for something else. So Wikipedia is in this case set pretty high level in terms of what they're writing. They wrote it for other psychiatrists, I think. But there's plenty of information out there about Piaget. And basically what he said is, in a nutshell, is that it's not just a quantity of thinking that a child changes as they grow up, but the quality as well, that they actually think differently. The very first one is basically the kid is a baby to about 2 years old. We're not going to worry about that because you're not going to work with those kids. If you're interested, read about it. And then pre-operational is up through somewhere about 5 to 7. From 2 to up to about age 7, they're pre-operational, and I'm not going to define what it is or tell you. I'll let you read about it. Not the purpose of today. And then we go into concrete operational and formal operational. And formal operational is something that can change somewhere around about age 14. I don't have any proof of this, but ever since I read about Piaget back in the 70s, I've thought that science classes in particular, and especially the demonstrations and labs that we do, can help the kid change from concrete operational to formal operational. Now, back in the 70s, it was said that you could run a very nice, good life on a concrete operational level. That even a doctor, no slam against doctors, but doctors didn't have to be formal operational in order to be a good doctor, because a lot of what the doctors did is memorization. Still is. I mean, you go in to the doctor and say, look, this, and this is happening to me, and he says, why, that's that. And here's a drug that I'm going to give you. And they have to know all that stuff because we just expect that. But things are changing now, with working on the computers and such. I'm thinking that it's much more likely that if you want a good job, you're going to have to be formal operational, and it doesn't always change for everybody. Not everybody makes it to the formal operational level. It takes a little extra push, and I'm thinking, with no proof, that science classes, in that we push them to do labs and do this is how we do it and this is how we take it step by step, that it will help the kid transition to formal operational. Okay, be that as it may, the pre-operational to concrete operational has an interesting thing that I just have found fascinating, and it's true. That if you have the exact same amount of water, and I measured it out with my beaker here, coffee cup, and I put into this glass 300 milliliters, and this glass 300 milliliters. Now, if you ask a pre-operational kid, someone who is younger than somewhere between 5 and 7, which glass has more water, most kids will pick the tall glass because it just looks like there's more water in there. A few kids will say this glass has more water because it's fatter. And I wish I had better glasses, but I couldn't find a really fat one. Excuse me. So anyway, and what I find really fascinating is that for a kid of a certain age, if you take a glass like this and pour it into this glass, that most kids will say that there is more water in this glass than in this glass, even though you poured the water from here into there. And that's because as adults and as older children and whatnot, we have conservation of material kind of firmly fixed in our head, that we know that the amount of water doesn't change just because you pour it from one glass to another. But a kid young enough will say it changes, the amount of water, how much water you have, changes as you pour it from glass to glass. And some of them will be rather adamant about the whole thing, that it changes. So I could pour it back and forth, and other than a little spillage here, it would change. Now, what I find fascinating is that the change from pre-operational to concrete operational appears to happen fairly quickly. And so if you talk to a child and say, oh yeah, it changes, I guarantee it changes, there's more water in the tall glass than in the short glass, then something happens to their head, and what it is, I really don't know. Maybe Piaget knew, I don't know, but I don't. And all of a sudden, the conservation of material kind of locks into their head, and you say, which has more water, this glass or this glass? They'll look at you like you're a flaming idiot. Because of course, it's the same amount of water, you just poured it from one glass to another. And so, if you're lucky enough to teach first grade, or pre-kindergarten, kindergarten, whatever, in there, you might try this and see what they say. It might be very interesting. And then if you try it with like a second grader, they might very well look at you like you're, like I said, a flaming idiot, because they know that the water doesn't change. And so there's other things that you can do for concrete to formal operational. They are a lot more complicated because it's a lot more subtle than something this easy. So, but anyway, but I wanted to do this as a little introduction to Piaget, in case you didn't cover him in your studies in school. Okay, thank you.